Ladies and gentlemen, welcome to another vodcast on 1D kinematics. We're going to focus today on acceleration and direction. I'm hoping this vodcast will serve as kind of a review of concepts that we've covered already. I'm not really going over any new material today, but I'm kind of going back over some material that we've mentioned briefly in previous lessons. So let's jump right to it. You can see on the screen some vocabulary terms from this unit. Things like distance, speed, displacement, velocity. And so at this point you should have a pretty good grip on what a lot of these mean and also their relationship, the relationship between them. So I want to clarify some of those things now and then use that as a springboard to emphasize some concepts about acceleration. So let's look here at the first set of relationships. We have distance and displacement. Now you probably know that they're related, okay? But do you know how? I've spoken about this previously, so let me clarify some things here. Basically, displacement is distance with direction. Okay, distance in a given direction. So I'll write that like that. Okay, distance with direction. And velocity, really, you could also define it similarly as well. Velocity is speed with direction. Okay? And what that means practically, right, is that when you give just a distance, okay, so let's go back up here to distance. The unit of distance is meters, right? So we might say a person walked 10 meters. Okay, 10 meters. And that would be a distance. But what if they walked, what if you wanted to be more precise? What if you wanted to give a direction? Let's say they walked 10 meters in a given direction. Well, then you might say 10 meters west. Okay? Well, this is considered a distance because it only has a magnitude. Okay? It only has a magnitude. Whereas this over here is considered a displacement because it has both magnitude, right? It has both size and direction. Okay? Velocity works similarly. We might have 5 meters per second as a speed. Okay, so the magnitude of velocity is actually considered the speed, right? Equals the magnitude of velocity. That's what it just so happens that velocity's magnitude has a specific name. It's called speed. Okay, now if we wanted to give a velocity rather than a speed, we'd say 5 meters per second north, for example. Okay. Now, positive and negative come in because west and north are not mathematical expressions. So when we want to come to use our tools, right, our equations, we can't put west and north into a formula. But we can put positive and negative. Okay? And that's where positive and negative velocity and displacement come from. They are merely direction. They're not some sort of weird negative space thing or somehow going slower than zero, right? Negative 5 meters per second is not slower than zero. It just means 5 meters per second in the opposite direction. Okay? And so now we come to acceleration. And acceleration doesn't really have an equivalent over here, right? A magnitude equivalent. But acceleration is what it does have direction as well. So the way that I might write acceleration is something like this, right? 3 meters per second squared, comma, south, right? I do need to specify in my acceleration what the direction is. And that's kind of what I want to focus on today, is because students really get tripped up when they try to think about the direction of acceleration. It just really doesn't sit well, doesn't click at all. Okay, and so that's what I want to focus on today, is the direction of acceleration. And in the process of that, we're also going to again revisit negative acceleration versus deceleration. Okay, so our goal today really for you is to feel more comfortable with determining what negative acceleration is and how it affects an object in a problem. As I've mentioned to you several times, the key to your understanding acceleration is going to be for you to understand the direction of the unbalanced force. That's why we learned about forces at the beginning of the year, so we could be better oriented to figure out which way acceleration is, because acceleration goes as the unbalanced force. So I'm going to pull up an example problem here, and if you keep in mind the direction of the unbalanced force, acceleration is going to be pretty easy for you. So let's look at that problem. Okay, here you see the example problem, and it's about a car moving in a given direction. Okay, and you can attack this problem by the same problem-solving method that you've learned, SCLEPS. Okay, so we're going to start with that, sketch and a coordinate system. Remember that the ideas of positive and negative acceleration, or positive and negative velocity, or positive and negative displacement, that's really all about direction. And so if you can get a picture of the problem, okay, that's really going to help you. That's going to go a long way to help you get an idea about what's going on here. So it appears that this car is moving to the west. Okay, so typically on a piece of paper, to the west is left. Okay, so I'm going to draw this car moving to the west, like so. And it starts at 6.5 meters per second. Okay, and apparently at some later time it has a velocity of 4 meters per second. So what do you think? Slowing down or speeding up? That's right, slowing down. Slowing down it is. So this car is slowing down. So you might want to ask yourself at this point, is it experiencing a positive acceleration or a negative acceleration? You can't answer that until you've gone to the second step, which is to set up a coordinate system. Which way is going to be positive? Well, again, typically you get to choose, right? You, the physicist, gets to choose. But I'm going to call to the right positive. Okay, that's sort of the default. You don't have to do that way, but typically do. And I'm going to set up my origin right here where the car is at the beginning of the problem, so I'm at 0 right there. Okay, now watch what happens. Okay, what that means is the following. These velocities actually become negative velocities, right? It's a negative 6.5 meters per second because in my coordinate system to the right is positive. So that means to the left is negative. Negative 4 meters per second, right? So I have to translate these numbers into my coordinate system. Okay? All right. We could solve this problem, okay, but we've covered that previously. What I want to focus on here is what is the direction of acceleration and what is its sign? All right, so I want you to think about if a car is moving to the left but it's slowing down, which way would you have to push on that car in order for it to experience this slowing down? Wouldn't you agree with me that the force on it, the unbalanced force, would have to be to the right? Right? Isn't that true? Wouldn't the unbalanced force have to be to the right? Wouldn't you have to push on it to the right to get it to slow down if it were moving in the left, right? So we'd just put F here for unbalanced force, or unbalanced force is also called the net force, okay? And therein lies your answer, right? Man, that's an ugly arrow. Whew. I bet I could do better now. Let's see here. How about this? Yeah, much better. So, actually not much better, much uglier. Let's try it again. There we go, okay? So, because you would have to push on this car to the right to get it to slow down in the way it is, therefore your push is to the right, okay? And therefore your acceleration is to the right. Right? So we'd say A to the right. And since to the right in your coordinate system is positive, we say that this is experiencing a positive acceleration. Now I know that's blowing your mind because in your mind, ingrained deeply, is this idea that positive acceleration is speeding up. But remember, and when we talk about acceleration in physics, positive acceleration is merely acceleration in a positive direction, which is a push in the positive direction. Okay, so like I said, we could go on to solve this problem. In fact, I think this is the one you'd want to use. Okay, I'll leave that to you as practice to do on your own. We're going to do one more problem over here, one more example. Okay, and just to see if you're really getting this acceleration stuff. So let me pull that second example up. Okay, here's the problem. It's pretty similar, except this time we're just talking about a person. They have a certain initial velocity, and then they experience a certain acceleration for a period of time, and we want to know what happens to the person's speed. So it's the same type of problem, except I'm giving you different numbers, right? Instead of the initial speed and the final speed, and you find the acceleration, I'm giving you the initial speed and the acceleration, and you find the final speed. So again, the first step here is to be able to visualize this. So think about if you can visualize this correctly, okay, and I'm going to draw it here in just a sec. Okay, you can see my visualization of this problem. We have a person walking. It says -5, so I chose to the right as positive again. That's indicated down here by this bigger arrow. I chose my coordinate system, my origin, right, where the person is at the beginning of the problem, and I made to the left negative. Okay, so I want to know what happens to this person's speed, right? Obviously, there's only two choices since they're experiencing an acceleration. They're either speeding up or slowing down. They could be changing direction as well, depending on how long the acceleration lasts, but we won't worry about that now. So think about it. If this person is experiencing this acceleration here, right, of -1 meters per second squared, what does that imply about its direction? Okay, in other words, if the acceleration is negative, okay, if the acceleration is negative, what is the direction of the push on the person? Isn't it also to the left, right? Because isn't that what Newton's second law tells us? That if the unbalanced force is in one direction, so is the acceleration, and vice versa. So you know that basically this person is being pushed on to the left, okay? And they're already moving to the left. So what's that going to do to their velocity? Isn't that going to increase it, right? So that's exactly what happens. In fact, they speed up to the left, okay? And I can actually use arrows to show you that by drawing over here. Okay, I can draw over here a longer arrow to show that the velocity went from 5 to something larger. In fact, this one's, again, I picked some pretty easy numbers, all right? If you experience an acceleration of this for 2 seconds, right, that means each second your speed changes by 1 meter per second, and after 2 seconds you have a speed of that, okay? So, again, counterintuitive, right? You experienced a negative acceleration. Ingrained in students' minds is the idea that negative means slowing down. But in this case, you see an example of negative acceleration speeding a person up. Because again, negative acceleration, right, doesn't mean slowing down. It means acceleration in a negative direction, which means being pushed in a negative direction. And that kind of goes back to what we talked about a few lessons ago, right? If you come back to this part of the screen here, okay, that negative acceleration and deceleration aren't the same thing. Okay, in this problem, the person was not decelerating. They were experiencing a negative acceleration, but it caused them to speed up, not slow down. All right, that's a wrap. I hope today helped you clarify some of the concepts that we've covered previously and that you come charging into the next class period ready for that quiz. Good luck.